everyone. In this video lecture, we'll learn about non-deterministic FSM, its definition, difference between DFSM and NDFSM, and example on non-deterministic FSM. A non-deterministic FSM M is a quintuple represented as K sigma delta S comma A, where K is a finite set of states and sigma is a alphabet. S is a start state which also belongs to K, and A is the accepting state or final states, or can be called. So A is also a subset of K, and delta is the transition relation. It is a finite subset of K cross sigma union epsilon into cross K. That means here the input can be either from the set alphabet, or it can be epsilon or empty. In other words, each element of delta contains state, input symbol or epsilon, pair, and a new state. So this is mapped to a new state, which is a subset of K.
Now we'll see the difference between DFSM and NDFSM. DFSM stands for Deterministic Finite State Machine, and NDFSM stands for Non-Deterministic Finite State Machine. And you can also write the definition of DFSM and NDFSM. In such machine, there is always exactly one move that can be made at each step, whereas in NDFSM, in which there may, at various points in the computation, there can be more than one move from which the machine may choose. For each symbol of the alphabet, there is only one state transition in DFSM, and no need to specify how does the NDFSM react according to some symbol. We don't, in case of NDFSM, will not show the transitions on all the input if it is all the alphabet, if it is not required. DFSM cannot use empty string transition. That means epsilon is not allowed in DFSM. NDFSM epsilon is required. In DFSM, next possible state is distinctly set. In NDFSM, each pair of state and input symbol can have many possible next states. Next we'll see DFSM is more difficult to construct. NDFSM is easier to construct. Time needed for executing an input string is less. Time needed for executing an input string is more in case of NDFSM. So less in case of DFSM and more in case of NDFSM, the time. Last one we'll see DFSM requires more space and NDFSM requires less space than DFSM. Now we'll see the example. Now let us draw NDFSM for the language W belongs to A, B star. That means here the strings are of A and B, such that W is made up of an optional A followed by 0 or followed by AA and followed by 0 or more P's. You can see here, this is the rule, right? This is the rule, followed by A followed by 0 or more B's. Now first we need to draw an NDFSM. That is, first I can tell, first we need in the NDFSM, first we need to identify an optional A. So how do I write a state for this? Before that, before writing optional A, I will write for A. So that's why to identify A, I need two states, Q0 and Q1. How do I make it optional? Optional by for the same transition, that is, I can make this A as optional by escaping this transition. How do I escape this transition? By taking epsilon transition. This is an empty string. Even if you don't supply input from Q0, you can jump to Q1. After that, optional, this will give you optional A. Then after optional A, you have two A's. How do I identify two A's? For the first A, you take one more state, and for another A, you take one more. So this will give you AA. Then followed by 0 or more B's. Now When I say 0 or more b's, that means what is the requirement? Till AA it is required, followed by that even if you don't supply B also fine. That means you have to make Q3 as a accepting state. Now, after if in case if your input contains B's, many B's, how what is the how you can accept it? That is through a self loop. So you at Q3 you have to make a self loop on B. So this will take 0 or more B. 0 B means it will after reaching Q3 it will remain at the same state. If you supply more B's, then it will loop here. So that's about NDFSM example.